How do you prevent thermal stress in heat exchangers? Imagine a metal pipe heating up and cooling down repeatedly. Without proper precautions, this can cause cracks or even break the equipment. That's why managing thermal stress is so important in heat exchangers. When parts of a heat exchanger heat unevenly, they expand or contract at different rates. This uneven movement puts stress on the materials and can lead to damage over time. To prevent this, engineers use several practical methods. One common approach is designing for thermal expansion. They include expansion joints or flexible connections that allow parts to move slightly as temperatures change. These features act like shock absorbers, reducing stress on the structure. Another key factor is choosing the right materials. Materials with similar thermal expansion rates are paired together to minimize differences in how they grow or shrink. They also select materials resistant to corrosion and thermal fatigue, which helps them last longer under temperature swings. Conducting thermal stress analysis before building the heat exchanger is also vital. Using tools like finite element analysis, engineers can see where stress might concentrate and adjust the design accordingly. This step helps identify weak spots and plan for safer operation. Controlling how quickly the temperature changes is equally important. Rapid heating or cooling causes sudden expansion or contraction, increasing stress. By gradually raising or lowering temperatures during startup or shutdown, operators can keep thermal stress at manageable levels. Proper support and anchoring of the heat exchanger is another simple but effective method. Supports should hold the device steady while allowing for expansion. This prevents excessive movement that could cause damage. In some designs, adding partial fin matrices or heat dissipation features near critical joints helps spread heat more evenly. This reduces local thermal expansion and stress. Regular inspection and maintenance are also necessary. Checking for cracks, deformation, or signs of fatigue allows early repairs before major failure occurs. Keeping surfaces clean prevents fouling, which can cause uneven heating and increase thermal gradients. Repairing damaged parts quickly ensures the heat exchanger remains safe and effective. Combining thoughtful design, suitable materials, controlled operation, and routine maintenance helps keep thermal stress in check. This approach extends the life of the equipment, improves safety, and maintains efficient heat transfer. Understanding these principles makes managing heat exchangers easier and more practical in real-world settings.